Welcome back, welcome back, welcome back. I'm Lisa Blackburn, and this is my YouTube channel for everything I like to talk about science and math. And today this is physical science. This is actually part 4 of the notes, but this is day 2 because we kept stopping it last time. All right, so what we just went over was how to write the formulas for ionic compounds. And what you do is you crisscross applesauce them. So, but I rolled up too high. So what you do, I'll write it over here on our thing for the people who weren't here. Where did I put my pen? Here's one. So anyway, yesterday we ended talking about calcium fluoride. So if you have, I'll write down here, if you have calcium and you look on the periodic table, calcium is in the second column, so it gets a charge of +2. Fluoride is over here in this column when the pattern is 1, 2, 3, skip, -3, -2, -1, zip. So it's in the -1 column, so we'll put fluorine -1. If I want to write the formula, I crisscross them and write it down at the bottom. So it's Ca1F2. You write it at the bottom with no charges. Now, technically, you don't normally write the 1, it's understood. Because we want to be as cool as math. Math has understood ones, right? So we want understood ones also. We want to be just as cool as math people. They're known for coolness, right? Mathematicians. I'm getting no. Okay, so that's the thing. Now, so what we're going to talk about next is naming them, okay? So how do you name them? Now, we already said, like, NaCl is table salt, but it has another name. It's chemical name. And does anybody know the name of NaCl, its chemical name, what we call that? Sodium chloride, okay? We don't call it sodium chlorine, we call it sodium chloride. So this is how you name them. What you do is first you name the metal, then you name the non-metal, and then you add IDE. So it's sodium chloride. You drop the regular ending and add IDE. So this one, what is the name of Al? What is Al? Y'all had your names test. What's Al? Aluminum. So this one's first name is aluminum. Aluminum. And what's Br? Bromine, but we're going to drop the "ene" and change it to "ide." Yes.
I think
We skipped something on y'all's notes? Oh, yep. I need to roll back. Go ahead and write this and then we'll go back.
Do you want me to do it from here?
Yeah. Click on it and then roll back. We did skip a blank. So.
Oh, it didn't do that.
It messed it up.
Where was this?
Don't worry about it. We'll erase it.
It didn't work for me.
Sorry about that. Technical difficulties.
It's not letting me roll it up in there.
Then close it all out and start it over.
Oh, sorry.
That's all right. Just reopen it.
What's it called? Is it,
Go to
down there?
go to Word down here in the corner. Like close that out. You go down here. Yeah, click that one.
Oops.
You go to Word. Yeah, click that, and it should come up. Yep, right there.
Top one?
Top one. And then scroll until we get. Oops, back. Wait a minute. We did that one. Yeah, you're right. We already did that. We're on right here. Crisscross applesauce worksheet binary. Yep. Okay, so yeah, just stop it right there.
Okay.
Or you can go ahead and do that to the top where it says, go back up. Oh, no, right there.
Is that good?
Worksheet, yep. Okay, sorry about that. So you do the metal first, the cation. Remember, cats are positive, anions, are negative. And then you do the negative thing, and then you add the ending IDE. Okay, now what did we say the name of this one was? What's its name? We can't name it Fred or what? Aluminum bromide. Everybody understand how Deshaun knew that? You just name what they are, but change the ending to "ide." Now these are binary, meaning two. And not all of them are that easy, but all the ones you're going to do is that easy. Chemistry is going to have to do harder ones, but y'all are not. So what's the name of NaCl? Somebody say it loud. Sodium chloride, so write it down. The first name is sodium, S-O-D-I-U-M. Sodium chloride, not sodium chlorine, sodium chloride. All right, now here are some exceptions I want you to know exist, but you do not have to do this on the test. I just want you to know it exists, because if you're reading your toothpaste and there's some chemicals on there, you're like, okay, I'm supposed to know how to name chemicals now, and I don't know how to name this. I want to tell you what it is, okay? So there's one thing called polyatomic ions. What does poly mean in Latin? Do y'all know? What? 5 is pent. You're close. But pent is poly. Poly is many. So like Polytechnic used to be the name of some colleges, meaning that they had different kinds of engineering, not just one. So poly is many. Polyatomic is, these are more than one atom that act together as one. So one of the ones you hear is sodium hydroxide. That hydroxide is made out of an oxygen and a hydrogen stuck together. There are 2 atoms, but they always are together and act as one. They're sort of like a little married couple or a married family or something, because it's not just 2, and we're not going there. Okay, so the names are given to you guys on a sheet. Now, for they're given on a chart. Now, where you will find them, in case you ever need to see them, is this is the periodic table I give you on the test, and on the back are the polyatomic ions. So you can see that hydronium ion, the ammonium ion. So a lot of the chemicals, when you read their names, it'll have these names off of this chart. So now I just want you to know what this chart was and what it's used for, but you are not going to have to actually use the chart. Yay. Okay. So it's on the periodic table I give you. There's another one. There are ancient metals. See our little ancient Greek guy there? There are some metals that have been around since BC times. Okay. The gold has been around a long time. Iron has been around a long time, right? These really ancient metals have ancient names, okay? So some metals have, and also these ancient metals can make more than one ion. They're not just 1, 2, 3, skip, -3, -2, -1, zip. They can have more than one ion. And then how they are named is the cation, the metal, is followed by a Roman numeral. See, I told you it was ancient. Remember those Roman numerals you learned? Did y'all learn those in what, 3rd grade? I is 1, 2 I's is 2, 3 I's is 3, a V is 5. Do y'all remember that? Did y'all learn your Roman numerals? That's why you had to learn them. And so you will see this sometimes, these names with Roman numerals. Now, in the 80s, the dark ages of the 80s, when I was a teenager, we were told that they were always going to use the Roman numerals from now on. But they also have ancient names that are based on its Latin name. And I was told that those were going to go away. We were just going to use the Roman numerals. They lied. I was also told that we were going to the metric system in the 70s. They lied about that too. So you still see the Latin names all the time. You see it on toothpaste. You ever read your toothpaste ingredients and see stannous fluoride? That stannous is Latin for tin. So you still see you'll still see ferric, you'll still see cupric, you'll still see these Latin names around. So I just wanted you to know that when you are reading chemicals, there'll be ones you don't understand. Sometimes it will be its Latin name, and sometimes it will be polyatomic. You do not have to know either one for the test. Okay, you don't have to be able to name something with its Latin name. You don't have to use Roman numerals. You don't have to name things that are polyatomic. Chemistry has to do all that. So if you take chemistry next year, you'll have the fun of doing that. But physical science, we don't go as deep into chemistry so that we can get to physics. So we get to learn something different than what they learn. You just learn different. Okay, so here's an example. Ferric is iron 3. So if you see ferric, that's iron that makes a +3 charge. Ferrous is iron 2. See my Roman numerals? Ferrous is iron that can make a +2 charge. Okay. Now then, so I just wanted you to know what that was. So here's another thing you need to know. When ionic compounds form, they arrange in crystal lattices. That's pretty, isn't it? Crystal lattices. Anybody ever seen rocks that are crystals? Sometimes they have shops that sell them, kind of hippie shops, little new age shops. And then you can wear little crystals and stuff. That would be an ionic compound. One where the atoms are arranged in crystal lattices. They're pretty, aren't they? Or have you ever cracked open a geode and there's crystals inside? Has anybody ever done that? I've never found a geode out in the wild. I've never done that. But in some areas, they have them where you can find them in creeks and you can bust them open and see the crystals. I've never done it. Have any of y'all done that? Those would be ionic compounds on the inside in crystal lattices. Diamonds, are in a crystal lattice, and a lot of our jewelry. So, ionic compounds have certain characteristics we're going to learn in the lab. And on the test, I'll have a lot of characteristics, and you're going to tell me if they're characteristics of ionic compounds where electrons are transferred, or if they're covalent where electrons are shared. And you're going to learn that with the lab. After we do the lab, we'll come back to the notes and list them here in the lab, in the notes. I don't want to tell you everything. I want you to have the fun of discovering it when we do our lab. It's a fun and stinky lab. It's a little bit stinky, right? Stinky. It's a little bit stinky. Lab's sometimes a little bit stinky. It's part of science. All right, so we're going to list them here. Will you try to roll up for us, Miss?
Try this again. Let's see. So I click on it, right?
Mm-hmm. Try click on it and see if it'll roll. Oh, it's working now.
Okay, where do you want to go to?
Covalent bonds. So that's ionic. Electrons are transferred. Now we're going to talk about covalent, where electrons are shared. So remember, ionic are the people, the bad parents leaving their little babies at Walmart, the crazy people stealing babies from the hospital, or adoptions, where one gives up their baby freely to another one that causes them to have ions, charges, opposites attract, they get together into a compound. So that's salt. That's what's going on with sodium chloride. We like salt, right? Salt on popcorn with butter, that's yummy. We love ionic compounds, okay? The next one is our covalent compounds. Ionic is between a metal and a nonmetal. Covalent is between two nonmetals. These are our divorced parents who work out sharing arrangements. Guadalupe, you paying attention? Put your phone away. Gotta pay attention. Okay, so covalent compounds are between two nonmetals. So on the test, you'll be able to recognize what's ionic or covalent by knowing if they're metals or nonmetals. The second thing is they share a pair of electrons. So these are divorced parents who are sharing two kids. It takes two electrons to make a bond. It's a pair of electrons, okay? They usually do not share the electron equally. We talked about that yesterday, didn't we? That most divorced parents do not equally share the kid. They don't go mom on Monday, dad on Tuesday, mom on Wednesday, dad on Thursday. I've only known one family who did that. and they moved next door to each other, and the kid would spend every other day at the other house. So they shared their kid equally. Everybody else, one of the parents gets some more, right? And that's how it is with most of our elements. The only ones that share them exactly equally is when it's the same element. So if it's two oxygens bound together, they share the electrons equally. If it's two nitrogens bound together, they share the electrons equally. Okay? So they only do this when they're bonded to an identical atom. So that would be diatomic molecules. Di means two, right? So a diatomic molecule would be like nitrogen, hydrogen bonds to itself, oxygen bonds to itself, chlorine bonds to itself. Those are called diatomic. Okay, chemistry has to memorize it. Also, there are some bonds where carbon will bond to carbon and it would share equally. So that would be in ethane. So you see something like that. The stronger one gets the electron more. So one of the electrons is stronger. We don't just call it stronger because that's not real sciencey. We call it more electronegative. But the one that's stronger gets it more. So this causes the bond to have a positive and a negative side. The stronger atom keeps the electron more. Electrons are negative. It makes it where it has a negative side to it. And our classic example of this is one of our favorite molecules, water. I always say that water looks like unimpressed Mickey Mouse. But my kids who I've been teaching keep saying, no, he looks like Kermit the Frog. What do y'all think? Is it Kermit the Frog or Mickey Mouse? Mickey? Okay, so the oxygen is the stronger one, and it keeps the electron more. So the oxygen becomes slightly negative. The ears, or the hydrogens, they don't get the electron so much, they become slightly positive. If it wasn't like that, then we would not have life on our planet. The fact that water has a positive side and a negative side is one of the main reasons we have life. Why? Well, it has to do with a lot of things. One is our Earth would die. Our Earth is covered in oceans. The oceans, because water has a positive side and a negative side, it sticks to itself. The negative side will attract another water molecule's positive ears, because opposites attract. Does that make sense to you? These positive ears will attract another water molecule's negative mouth. So it makes the water stick together. Have you ever noticed how water beads up? You put water on your finger, it makes a little bead of water. It's because it's sticking to itself so hard. Because it sticks to itself so hard, it takes a lot of energy to heat it up. And once it heats up, it takes a long time to cool off. So where other planets get too hot in the day to sustain life and too cold at night to sustain life, Earth keeps a nice temperature. Day and night, we can stay alive. During the day, the oceans heat up and keep it from getting, and they absorb a lot of the sunlight, and they keep it from getting too hot to kill us. And then at night, when the Earth turns away from the sun, the oceans give that heat back to the Earth and keep it from getting too cold to kill us. We couldn't live on other planets. It gets too hot in the day and too cold at night. But because we have water and it has a positive and negative end, we can have life. That's nice, isn't it? Another reason why water makes life is because trees couldn't drink if water wasn't sticky. Trees don't have a heart. They don't have a circulatory system. How do they get the water out of the ground all the way up to their leaves? They do it because water is so sticky, it clings to itself so hard that it can crawl up the little veins it has. Remember the xylem and the phloem in biology? Did y'all learn about that? About the tubes in the plants? The water is so sticky, it crawls up the plants. If there were not plants, we wouldn't have oxygen, we would die, wouldn't we? We need plants to eat, and we need plants to make the oxygen we need to live. So water's really important for that. Another one is, do you know if the lakes and the oceans die, we die? You know how we're all interconnected? Remember learning that in biology class? Because water sticks to itself so hard when it's a liquid, when it becomes a solid, it spreads out. And when it does, that makes ice float. If ice didn't float, every time it got below freezing, all the lakes and rivers and the ocean would die. Because in normal chemicals, the solid is more dense than the liquid. So when it got cold and if water froze normally, it would sink to the bottom. The water would go up and up and up until it all froze, and all the little fish would be up top flapping along and die. Does that make sense to you? But because ice floats, when it gets cold over water, the top part freezes into ice. Underneath, all the fish are down there just fine, alive. Do you see how that makes it where we have life on this planet too? If all the fish died, we would die. The fish support the ecosystem of the earth and makes it where we can live. And all of that is based on water having a positive side and a negative side. That's pretty amazing, isn't it? And there's a lot of other things like that too. It's really just astounding that we're alive. Okay, bond angles. Let's talk about that. So when these molecules form, they can have something called lone pairs. Let me make sure that I'm doing the right thing for y'all, because y'all's notes are a little different than the one I'm holding. Crystal lattices, covalent, water. Oh, you see how I have the earth over there? When atoms or compounds have a positive end and a negative end, it's called polar. So draw a little, it's just like how the earth has poles, the earth has ends, the atoms put together cause charges, which cause a positive end and a negative end. It's called polar. So water is polar. Oil is non-polar. And we're going to talk more about that.
I need an interruption. Would you please send Kaya Brewer to the athletic director's office?
We don't have Kaya Brewer. Like, she's not in this class. This is Miss Blackburn 803.
Yes.
Second period.
Yep.
Kayla?
Amaziah?
Oh, I have Amaziah.
I'm sorry, I mispronounced your name. Please send her to the athletic director's office.
Did you know that she was talking about you?
I think she probably did.
She said she did. Sorry about that. Thank you.
That's okay.
I got it, Amaziah. Athletic director's office. You don't have a pass, just good. All right. So the next thing is water having a certain shape. That gives molecules a certain shape. And we're going to do a fun little lab, where we're going to learn about that. What time do we get out of here, Miss Olivier?
11:22.
What?
Yes.
11, what?
20.
11:22?
11:21.
Okay, so we've got 40 minutes still, right?
We do.
Okay, good. Yes. Yes, just 1 second. Let me finish up this, and then we're going to do a little activity, okay? So we're going to learn something about bond angles. So I'm going to stop this, and in the classroom, we're going to do this little activity, and you wouldn't be able to see me anyway. So when you get back to school, I'll explain it to you, and I'll let you do it. So everybody else, we're about to do it. We're going to just sort of stop in the notes. I'm kind of incorporating labs as we do notes. And we're going to stop and do another activity like the Cheerio activity, okay? So like, share, subscribe. Come back for part 5.